my name is Manish Gupta, and in this video, I'm going to talk about Lumiere, space-time diffusion model for video generation. So let's get started. So let's first see what can Lumiere do, right? So let's look at this video, which is very popularly put up. It can do high quality video generation. So all these videos are not real. They are all automatically generated by this Lumiere model. It can also do text to video. So you can basically enter text prompts, as you can see at the bottom, and then it can generate a video, related to that one. It can also do image to video. So you can actually just give a first image and then it can actually, and then a text prompt to indicate what you want in the video. And it can actually generate these videos. So these are all generated using their first image of these videos as the image prompt. And then a text describing what you expect in the video. It generates those, right? You can also do stylized generations. You can give a reference style image here and then a text, a horse galloping. It can actually create a horse with the same bluish kind of, style. So similarly, you can give this, a golden yellowish flower kind of reference style image, and you see white background with golden yellowish things, or blue background with, drawing color kind of paintings, or reference style image is a Christmas tree with white background, green thing, and you basically see images created of that kind. You can also do cinemagraphs. So given an image, just figure out a particular part of the image that should be animated and animates those. You can do video editing. So you can take a particular video, highlight a part, which should be changed, and you can say what should be changed, wearing a striped strapless gown or whatever, and then it basically changes stuff. You can also do edits, change parts of the videos by doing text kind of edits. Okay, so this is basically what Lumiere model can do. So really awesome, right? I mean, essentially the capabilities are really good. Uh, so, but the current models, if you see, video generation is not easy. Actually, video generation is really, really tricky. So for existing text to video models, it is tricky because they do video generation in two steps mainly. The base model generates the distant keyframes. So the keyframes that it generates are far away from each other. And then there is a temporal super resolution model, which sort of increases the number of frames per second. So it sort of tries to make it higher fidelity in that sense. It generates the missing data between these keyframes, and basically in non-overlapping segments. So it basically just takes those segments and tries to fill in the keyframes. Now, while doing this kind of two steps kind of phenomena or two-step kind of generation, they basically introduce temporal inconsistency. So as you see in this video, this part, the left part basically shows videos generated by Imagen. The right part basically shows videos generated using Lumiere, right? And as you see in both of these videos, there is repetitive motion, right? But since because of this two-step kind of an approach, there is temporal inconsistency. Imagen sort of struggles to generate globally coherent repetitive motion, as you see. While on the other hand, Lumiere actually generates it very nicely. So Lumiere must be doing something interesting, which I'll talk about in the next few slides, so as to ensure this temporal consistency, right? So again, here there is temporal inconsistency, but here, as you see, the motion is pretty consistent. Okay. So these temporal super resolution modules are sort of constrained to fixed and small temporal context windows, and therefore they cannot really, they therefore cannot really lead to appropriate generation of these missing frames, consistent generation of these missing frames. Okay. So just to sort of again repeat and compare the two kinds of approaches, these are the traditional approaches that have been used for typical text to video generation. So essentially you have various timestamps, and what you try to do is to use some sort of a base model to generate images which are basically keyframes which are very large distance apart. Okay. Now this, for example, this one generates 128 cross 128 cross 16 kind of an image volume, which is 3 frames per second, and this is a segment of 5 seconds, 5-second segment, 3 frames per second. Okay. Now, if you basically look at it, so since it is 3 frames per second, this should be 15, more like 15, right? So 128 cross 128 cross 15. So basically 3 frames per second and 5 seconds. Therefore, you have a depth of 3 into 515. Okay. Now, if you look at it at the second stage, so this is the first stage. The second stage, a temporal super resolution module is applied so as to fill in these missing frames. So as you see here, the 3 frames per second basically now becomes 16 frames per second as you fill in more frames. Okay. And the 16 frames per second, of course, if you have like a 5-second segment, then you basically have a depth of 80 frames in that sense, or rather depth of 80 overall, right? So that is that. Now, after that, of course, the third step is common. So you need to do spatial super resolution so as to increase the space, the size of these frames from 128 cross 128 to 1024 cross 1024. Okay, so that's basically the three-step approach that typically older methods take. I mean, of course, the two-step to actually generate the video, and then the third one to especially super resolve it. I mean, create magnify the resolution, especially, right? But Lumiere actually uses the space-time unit, so which basically takes your input prompt. Now it could be text prompt, it could be image prompt, and so on. And then it basically directly generates higher resolution, higher temporal resolution images. Okay, so it directly generates the higher temporal resolution frames. So doing away with these TSR modules, which basically means that your temporal consistency is much better with Lumiere. Of course, it also has the second step of doing spatial super resolution, and it does so using a technique called as multi-diffusion, which I'll talk about in the next few slides, leading to even improved spatial super resolution. But the most important contribution is here. Rather than doing a two-step approach, it basically just uses a ST unit so as to directly compute frames frames which are very near to each other. So it basically directly does the base model plus the temporal super resolution in a joint manner. Okay. So Lumiere is a T2V, text-to-video diffusion model for realistic, diverse, and coherent motion. It basically uses a space-time unit architecture and generates the entire temporal duration of the video at once. We'll talk about what is space-time unit architecture next. So space-time unit architecture, of course, is a unit. So that's that. You basically take the original image and then apply either these convolution-based inflation block or attention-based inflation block, right? So as you see, convolution-based unit block, convolution-based inflation block is applied in all the layers except the last layer. Just the last layer basically applies this attention-based inflation block. Yeah. So basically, it takes a text-to-image unit model. So it initializes using the text-to-image unit model, and it inflates this pre-trained text-to-image unit model so as to essentially make it applicable for video generation use cases. In several of these steps, it downsamples and upsamples the video in both space and time. So notice, the original video or the original video is a TWH. So you have a H cross W height, and width is W, H is the height, and T is the temporal resolution of the original video, right? So essentially, as you see, these modules, they downsample both in a spatial manner as well as a temporal manner. So T becomes T by 2, HWD1 also becomes H divided by 2, W divided by 2, and D2. Okay. So there is downsampling and upsampling both in the space and time domain. It performs majority of the computation on compact space-time representation. So essentially, a whole bunch of this attention-based computation actually happens on the transformed video, which is basically much smaller in size. Okay. In the layers above, or rather in all the layers except for the last layer, it basically uses cheap temporal convolutions, except for the most granular layer, which has expensive temporal attention here, right? So if you notice in these blue blocks, what is going on? Well, you have first the pre-trained spatial layers, which are doing spatial convolutions. And then you also have like the 1D convolutions, which are happening around. So it's basically alternating the spatial and temporal, upsampling and downsampling. So that's basically that, right? Only in the last layer, you basically do this attention, which, multiple layers of attention, of course, which are time consuming, which are compute consuming in that sense. Okay. Now, the idea is that you actually use the pre-trained text-to-image models, but then you train newly added parameters and keep the weights of the pre-trained T2I fixed so as to actually ensure faster training, right? Lastly, after all of this STU unit is done, essentially, you also have this multi-diffusion guy right there for spatial super resolution. Multi-diffusion along the temporal axis is done to feed these segments of the video that has been generated so far to the spatial super resolution network, right? Now, while generating these spatial super resolution kind of things to ensure consistency, you make sure that these temporal windows which are sort of pushed to the spatial super resolution have an overlap of 2 frames. And at each denoising step, you essentially just average out the predictions of the overlapping pixels, and that gives you much more consistency. Lastly, you also do per segment spatial super resolution predictions, which basically helps you avoid temporal boundary artifacts completely. Now, how is Lumiere model overall trained? So basically, I talked about pre-training parts. Now, specifically for certain kinds of tasks, you can fine-tune it further. Yeah. So primarily the kind of task that I showed you in the video can be considered as two kinds, stylized generation and conditional generation. So in stylized generation, remember there is a style image that you pass as an extra input. And of course, you pass text prompt and everything else anyway. So typical diffusion models can take care of the text input that you pass. And the T2I, the stable diffusion kind of models actually do that, right? So they can actually take the text prompt and the time embeddings, of course, and then they can generate image. And then you have basically used it to bootstrap the pre-training for the text to video model anyway, right? But here you have an extra image, the style image, as you can call it. So therefore, what they do is to basically take the style image, also do the diffusion there, and then essentially you have the weights of the style image and you have the original weights. You basically interpolate them using a hyperparameter alpha, and that's how you basically get the overall model for stylized generation. Okay, which can basically take not just the text prompts but also style images to generate a video which conforms to the style as indicated in the style image. Okay. Overall, their model is actually trained on 30 million videos along with their text caption. They use 80 frame long videos as 16 frames per second and try to generate 5 seconds kind of stuff. The base model actually works in the range of 128 cross 128 sized images, but then the spatial super resolution helps them generate 1000 cross 1000 frames, which is pretty good resolution in that sense, right? Now, if we talk about conditional generation, you could condition on image or mask or text, remember? So for various use cases, so sometimes you need to pass on image and condition it based on that. Sometimes you need to pass mask because you want to say that, hey, just change this part of the video for video editing or for even cinema, cinematographs. You want to basically say, hey, just animate this part of the video or this part of the image and so on, right? And of course, you have text prompts. So therefore, the model inputs consist of a noisy video, which is basically the base thing for diffusion in that sense, is a text prompt, masked conditioning video C. So, sometimes this mask conditioning could be video, sometimes it could just be text. It could just be a single frame, right? Mask on a single frame. So we'll talk about this masked video in different use cases later, okay? But that's the mask basically C. And then you also have binary mask M. Okay? You also have binary mask M. Okay? Now, for image to video, when you're creating, remember image to video, you basically say that your C, the mask conditioning video, is the first frame followed by blank frames because you don't have a video, right, for conditioning at all. You just have basically your current image that you want to use for masking or other for influencing the generation of the video. Okay. So therefore, you just give the first frame and then followed by blank frames. And then the mask bits are set that they are ones for the first frame and zeros for the rest of the video. Basically saying don't, use this particular image for influencing the later parts of the video, but just use it completely to influence the first part of the video. Now, since the mask values are 1 for the first frame, it basically says that, hey, in the video generation, don't disturb the first frame at all. Just keep the conditioning image as the original image, as the image in the video also. Okay, so you want the video to start with the image that has been given to you, right? And then you basically want to follow it up with the variations based on this conditioning. Yeah. In inpainting, the idea is to, of course, replace objects or insert new objects or do localized editing, right? So in this case, the image mask conditioning video is the user provided video and a mask M. So basically the user could be saying that, hey, in this part of the original video, condition it based on this small video, smaller video. And then the user will also provide the mask. Hey, basically, I want to edit the original video based conditioned on a conditioning video. And well, this is the time duration for which the conditioning should be applied and so on. Okay. So this could be sort of used for object replacement, insertion, or any localized editing, right? Cinemagraphs, well, cinemagraphs basically means animating the content of an image only within a specific user-provided region. So that region has to be indicated in the mask. And C is the input image duplicated across the entire video. So you basically have to duplicate some stuff in the entire video. Well, let's do that as part of C. And then you have the mask, so which is basically once for the first frame, and for the other frames, the mask only applies. So it basically contains once only outside the user provided region. So if the user marks a region, you basically want to say that for that particular region, don't disturb anything, or other, for that particular region is the one where you're basically going to mask and change things, but everything else should remain the same, right? So that's basically the cinema graph. So essentially, Lumiere is practically a diffusion model. It rides on the pre-trained text-to-image models and, of course, inflates them so as to create them as a diffusion-based text-to-video model. And then basically it has these convolutions which basically are both in the space and time dimensions, so as to essentially give you a single one-shot generation of the video frames at higher temporal resolution. Of course, after that it uses multi-diffusion so as to generate the spatial super resoluted images. Okay? And then it has all these fancy ways of providing the input which enable various use cases based on what is the conditioning video and what is the binary mask that is provided along with the text prompt. So how does Lumiere perform? Well, here is comparison in terms of video generation qualities compared with various other popular video generation models like Make a Video or Stable Video Diffusion, Emo Video, and so on. Right. So what you observe is that Runway ML's Gen 2 and Pika, I mean, although they're not shown here, they also demonstrate high per frame visual quality. So if you look at one frame, they generate very awesome frames, but then they have very limited motion. So things don't change much. They're more like static videos, almost like near static videos. Okay. Now, models like image video, animative, zero scope, they actually exhibit noticeable motion, but they are prone to visual artifacts. So the motion is not consistent, and they also generate smaller length videos. On the other hand, of course, Lumiere performs much better. So these are results that you see here on freshet video distance and inception score. Of course, the distance being smaller is better, and also inception score higher the better. So what you observe is that, of course, Lumiere performs better than all of these models, including the stable video diffusion. They also did some human evaluation study, and they found that typically, if you ask people, hey, which one do you like, image and video, Pika, Runway ML's Gen 2, right? They basically found that most of the cases people actually liked Lumiere, both in terms of video quality and in terms of alignment of the video with respect to the input text for text to video use cases. They also basically got human evaluation done for image to video use cases, and they again found that the video quality as generated by Lumiere is better compared to Pika, Stable Video Diffusion, or Runway ML's Gen 2. Okay, so in summary, Lumiere is a text-to-video generation framework utilizing a pre-trained text-to-video generation framework utilizing a pre-trained text-to-image diffusion model. Right? It allows globally coherent motion using a space-time unit architecture, which directly generates full frame rate video clips. Both spatial and temporal down and up sampling modules are present in this unit architecture, in this space-time unit architecture. And they basically showed that this works really well for text to video, image to video, video in painting, stylized generation kind of use cases. They can overall, the model can generate 5-second videos with higher motion magnitude, temporal consistency, and overall high quality. Okay, so that's it for this video. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my search on my homepage.